Okay.
Hey guys, I'm Tajvar, and
And I'm Antaha.
I worked with yeah, and today we're going to be talking about CNN. So yeah, let's start. So CNN is short for Convolution Neural Network. It's inspired by the brain. So if you can see in this image, this one, what it does is basically it takes in images, it assigns weights and biases to different layers, and at the end, it classifies what that image is, and it can recognize basically everyday objects. So why use it? Basically, convolution neural networks try to reduce the cost by learning low-level features, for example, horizontal and vertical lines. And then the algorithm stacks these features to give us an abstract shape, like over here. So like the red could be representing like, I don't know, like a hair or something like that. So in other words, each concept is like a face, and its components can be distributed among the filters in cases where like the concepts and the distribution among different layers. If let's say if someone were to look at each one of them, they might be sophisticated. The information is distributed among them, and for understanding that information, all those filters and their activations has to be considered through, although they may seem so complicated. So let's talk about the
Wait,
inputs. As
Tajur,
I
I have a
said,
question on. Sorry, as I have a question on the previous slide. So
e,
what?
sorry,
Yeah.
yeah.
So what's the stuff in like the red, green, and blue boxes?
So we're
Is that like part of the image or whatever?
yeah, it's part of the image. Basically, from the website I took this from, it was saying how the the neural network took this image and put some features on it, like trying to find out the horizontal and vertical lines. And they gave an example that the red box would represent maybe a part of their hair or something like that. Or like this part would represent like a feature of their nose or eyes. That's what they were saying.
Okay, thanks.
So as I said before, convolution neural networks takes in images. As you may already know, every image is made of pixels. So now I'm going to throw some vocabulary words. So imagine you have like a digital camera and you took an image from there. You would have three channels, which is red, blue, and green, each having pixel values from 0 to 255, as you can see like right here. This is red, green, blue, right? So what you want to do with a convolutional network is to reduce the images into a form which is easier to process without losing features that are critical to get a proper prediction. So that's why grayscale is important. Basically, you try to convert an image to a grayscale, which is a single channel of like showing black and white. So 0 would be indicating black, and the pixel number of 255 would be indicating white. So as you can see over here, this image is in grayscale, and then you can see the pixel values underneath it.
Hey everybody, this is Michael. After the video, I just want to show to you a proper visualization of black and white matrix values in an image from the Stanford website. So this is a picture of Abe Lincoln's face. As you see, his more defined features have a value closer to 0. This is very similar to the color value of 0, which is hex 000, and the lighter values have a value of 255, or the less gray values have a value more like 253, 245, 241. The higher it goes to 255, that means white. And it's very similar to the color value of white, which is hex FFF, which is sort of like 255, 255, 255 on RGB. I hope you enjoyed this. Now back to the video.
Wait, Tajvar, Khal has a question in the
Okay.
chat you can answer.
Oh, sorry. Let me see. I have a question. Why do we use neural network for regression algorithms? I don't think, correct me if I'm wrong, but like using convolution neural networks isn't necessary. I feel like it'd be overkill. Just using regular neural networks would be fine. And you use a regular neural network because what you do is like you have the data and you're trying to find a proper fit line to be able to predict a continuous value. You understand what I'm saying?
Yeah, just to add on to Tajwar's point, convolutional neural networks are not typically used for regression. They're very often used for classification, like trying to classify an image. That's why you need so much power that you need a neural network. Regular artificial neural networks are more, you can use them for regression or classification because they have those things called dense layers. And as Tajwar and Muntaha will talk about, there's in convolutional layers, there's something called convolutional layers, and they do different things, and they like warp the data so that it's not possible for regression to be used. You have to use either like a standard machine learning model or a neural network. I hope that answers your question, Khao. Yeah, you're welcome.
No problem. Muntaha, you want to talk about this one now?
Yeah. So like Michael said, there are convolutional layers. So let's talk about the definition of convolution in case you're confused. It's kind of just like we just have to think about it like a math operation, like addition, subtraction. Convolution is its own operation, so it involves combining two signals to make a third, and it has an input, an output, and an impulse response. And we're going to be referring back to this picture for the next two slides. Tadra, can you go to the next slide? Okay, so convolutional layers are the building blocks of the CNN. So just like every like a neural network, the building block is a perceptron. For CNN, it's a convolutional layer. Each layer has kernels. Kernels are you have to think of it like a matrix, and if you don't know what a matrix is, because like you didn't take like pre-calc or you haven't been exposed to it yet, it's just it's like rows and columns of numbers that have to be multiplied in a certain way to create a product. I don't know how to explain a matrix, so Tadra, can you explain what a matrix is?
Imagine just like you have a table of X rows and Y columns, and you have numbers filled into it.
Yeah, if you guys
And
could go
then
back a slide, I can like maybe provide some insight. Yeah, so basically you can think of where you were before. So forward.
this one.
Keep going forward.
One more.
Yeah.
This one?
Yeah, that one.
Okay.
Yeah, so guys, basically you can think of a kernel as this like this square in the leftmost image, and basically what it's doing is it's going over each part of the image and it's looking for certain patterns in the image that are important for classifying the image. So for example, it could look for example, the edges on the boat, and then map that information to the next layer. So it's basically parsing the image for you can think of the kernel or convolutions in general as parsing the image for key patterns that will help the algorithm to classify it better. Yeah.
And in addition, that sometimes the kernel is also known as a filter. That's how it's called programmatically.
Thank you, guys.
Okay, thank you. Okay, yeah. So they already explained what a kernel is. So the purpose, like the function, is to extract features that are useful to what you're looking for. For example, if you want to sharpen an image that's like blurry, like features like that. It is used for linearity, like Tadar already explained, and it scales the feature, so it reduces the dimensions of the feature, which will scale it and make it easier for translation. Tadar, can you go to the next slide? So when we go back to the first image, you'll see two sets of convolution. Yeah, sorry, you're gonna have to be moving back and forth a few times. So you're gonna see
Okay.
Actually, hold on. Let me just pull up the slides on my phone so you guys can focus on the image. Okay, so there are, sorry, one second. Chandra, can you just go back to that slide?
Yep.
Okay, now you can go back to the photo.
Okay.
So you'll see that there are two sets of convolution. So they're known as ReLU and pooling layers in this specific example. It's just easier to refer to an image than just talking about it theoretically. So here you are using 6 filters to get to the second convolution layer. So it first performs convolution on the first pooling layer. Yeah, where Tadro's, yeah. So this will result in 6 feature maps. That's what they're called. And then ReLU will be applied to each individual map. Can you go to the third slide?
This one?
Yeah. So then there's something called a fully connected layer. So a fully connected layer, why it's important is mainly because it is a cheaper alternative to learning nonlinear combinations. So in this one, the input of, one second. The input of this layer is, can you go back to the image? So the input of this layer is from the output of the second pooling layer. So you keep going down this line. And in this step, all your neurons are connected, which is why it's called the fully connected layer. It will use these stratified features to classify the input image into classes using a training data set that's already known. And we'll talk about classification later. Also, the sum of the outputs from the fully connected layer is 1. So by using activation functions, by using activation functions, which we covered 2 meetings ago, activation functions are used to give you data, give you output in a set of ranges. So in this one, they use the softmax as an activation function in the output layer. So it takes a vector of an arbitrary score and squishes it into another vector of values between 0 and 1 that will sum to 1. Okay, that's it for this.
Mantaha, may I interrupt and just add on some information?
Yeah.
So this fully connected layer, this is very, very similar to when we covered artificial neural networks, and is also called a dense layer. A dense layer is just what you would use for a normal neural network, and it's sort of like those hidden layers, and you can kind of go more, like Mantaha said, you can kind of scrunch the data and kind of go full power with the fully connected layers. And just like we covered previously with activation layers for classification, which were sigmoid and softmax. Softmax is for multiple categories and sigmoid is for 2 categories. You can use the softmax activation category to get the the categories that the computer has predicted. So whether it's dog, cat, boat, or bird.
Yeah, and if I could add on to what Michael is saying, so yeah, essentially the fully connected layer is what you would see in a traditional neural network. So it would be your input layer in a traditional neural network. In order to get to that fully connected layer, essentially you start with your input image, and in your first convolution in this example, you're applying 3 different filters. That's why you see in the first white image 3 different layers. That's the result of applying 3 different filters. And then pooling layers essentially reduce the dimensionality of your.
Oh, we were gonna get to that.
Oh, sorry, my bad. Yeah, but that's essentially how you get to the fully connected layer. So you use a combination of convolutions and poolings to simplify the image so that you can feed it into a traditional neural network. All right, that's all.
Yeah, thank you guys once again. So as Montaha and Zach said about pooling layers, it's meant to reduce dimensions and keep the most important information. It's similar to convolution steps, but it extracts the most dominant features. So it reduces computational power used to process the data. And now I want to talk about spatial neighborhood, which is like the window you're pulling over. So if you can see like this GIF, whatever you call it, it has a spatial window of 3 by 3. It's going by every 3 by 3 pixels, and then extracting the greatest number inside each of them. If you guys can see that, yeah. So I want to talk about two pooling methods that are very famous, that we most likely are going to use. It's called max pooling and average pooling. If you look over here, in max pooling, the algorithm for this case looks at a 2 by 2 window and then finds the maximum number. So like in this red window, the maximum number is a 20. That's why it outputs a 20. So an average pooling will find the average of each window. So again, in this red one, the average of all 4 numbers is 13. So max pooling also performs as a noise suppressant, which is ignoring the outliers. It discards any noisy activizations altogether and performs denoising along with dimensional reduction. But on the other hand, average pooling simply performs dimensional reduction as a noise suppressing mechanism. I would recommend using max pooling, but then again, it also depends on the situation, so use it wisely. Mandaha? Yeah.
Okay, so for classification, we use a definition. It's the act of predicting the correct class out of a set of data points. And I'm going to use an analogy to a person that is blindfolded to explain this. So when you look at this image, you see 2 ice cream cones, chocolate and vanilla. So let's say you had a person that was blindfolded and you gave them both flavors of ice cream, and let's say hypothetically they never tasted these before in their life. So they know that the vanilla ice cream cone, that's their only experience of tasting vanilla, and the chocolate, that's their only experience of tasting chocolate. So then you're gonna, after they taste it, you're gonna give them a new set of flavors. So let's say you have French vanilla or vanilla bean. So you make them taste it, and they have to determine whether or not that is considered a vanilla flavor. So obviously there are variables to differentiate these 2 ice cream cones, whether it's color, taste, like vanilla tastes better. We all know that. And then the same, so you just keep feeding it until until they're able to class the flavors into their own, into whether or not it's vanilla or chocolate. And if they do not taste it, let's say I give them like strawberry and it's not considered for either, it's considered false without prediction. I hope that makes sense.
So now we want you guys to try it yourself. I'll copy the link and then post it on the meeting thing. So Michael, do you want to explain what your collab is about?
Hey,
Okay, so
before we do that, can we give people
Oh.
time to ask like any questions?
Yes.
Yeah. Okay. So one question that I have is how do convolutions and pooling layers work together in a convolutional neural network? And anybody can answer this.
So I think Montaha was talking about it first. Oh shoot. So what you have is first a convolution layer that like combines 2 signals, right? But then the pooling layer, since after the convolution layer, like it's still processing the image, which is like taking too much power. The pooling layer, how it works was that it just takes the most important features and then simplifies the image, and then you do another convolution layer trying to understand like the more features, if that makes any sense.
Okay.
Anyone else want to add on? Thank you. Yes, that was great.
Thank you.
Okay, how's the question?
Okay.
I'm just going to read the question because the question might not be recorded. How do you know how many times you pull or use activation function? Is it guess and check?
Well, from what I know, pooling, I think you can basically use as many times. Like how I used it was I used a convolution 2D, and then I did max pooling, and then another convolution layer, and then a global max, I think, pooling. There's no limit, but then again, you might overfit your model. So be careful on how many like pooling and convolution layers you use. And as for activation function, I believe there's only one at the end. The one that we have mostly talked about was softmax. Another one that Michael mentioned was sigmoid. You use that at the completely last layer.
Yeah.
Wait. Okay, Tajwar, you did like a really good explanation, but I just want to clear up some confusion on maybe some K-House part. So how this
Okay, yeah.
you're gonna see this at the end of the notebook on that everyone's gonna open up. But typically, how a convolutional neural network is written is you have so when I say conv2D, that's called a convolutional layer. You typically have two conv2Ds, and then you put a max pooling layer because by now you've built up like a lot of huge numbers, like huge and small numbers from your convolutions, and you want to just limit the dimensionality so it's not too much math overflow and it's not taking too much time. So, and then in between each of the convolutions, then you put a ReLU activation or whatever activation you decide. So it usually goes conv2D, a ReLU activation, conv2D, max pooling, and then you can put something dropout. And is everyone familiar with dropout, or do I need to re-explain it? Please say something.
We should re-explain it.
Yeah, I also. Okay, go ahead, Michael.
Wait, what were you gonna say, Zach?
Yeah, I was just going to add on to the Com2D layers. So, yeah, you actually use activation functions a lot, not just exclusively in the like fully connected layers. So, for example, you could apply like a convolution and it would like spit out like, some array of numbers. And how you could apply an activation function to that is you could say, okay, the numbers that are negative, we're just going to make 0 because we don't want any negative numbers. And the numbers that are positive, we could, transform them or scale them somehow so that, they're easier to interpret. So essentially an activation layer is just taking whatever your last layer outputted and transforming it into a format that can be used as an input to the next layer, if that makes any sense. Yeah.
Okay, and I'm just going to re-explain dropout layers to everyone who's here because I think there's some new members that have joined. A dropout, this is like easily shown because I drew something in school that showed this, but a dropout layer is kind of imagine like you're doing a test and like you're doing it in the early morning and you're like focused, you ate breakfast and like you're ready to go, your brain cells are working. And then imagine doing the test, like you can imagine doing an AP test and then doing it at like 8 o'clock when you're like losing willpower. And you can kind of show that you lost this is not true neuroscience, but you like feel that you've lost some brain cells in the process of the time. So what dropout kind of is where like you give it a ratio. Usually it's between the max is like 1/2 and the lowest you can do is 0. And what dropout does is it cuts that ratio of quote unquote brain cells out from the neural network. So the ones that are still there have to be, oh my God, I have to remember this because all my friends are not there anymore. it's sort of, you don't have to rely on, like your friend is not there anymore. You just have to rely on them for memorizing the information yourself. I hope that makes sense.
Yeah, you can think of like the neurons in a neural network as like I have friends who can like hold information or whatever. They're each like containers where you hold information. So what Michael is saying is Dropout basically remove some of those so that the ones that are still there have to remember more information. And that's a way of that actually improves the performance of the neural network as a whole more times than not. So yeah.
Yeah, good explanation, Zach.
Yeah,
Also,
you too.
yeah, thank you. If anyone has any questions on the convolutional network presentation, or if you're just lost in general, you should ask questions now. Okay.
Can anyone explain why the output predictions have to add up to 1? Because I think that's an important point.
Can you repeat the question?
Why do the output predictions have to add up to 1?
Because you can go, Manchara.
Oh, well,
You can say it.
is it because like in regression, the values are between 0 to 1, so it has to add back to 1? I'm not sure.
I thought it was like because like 100% if it's a value between 0 and 1 and it all adds up to 1, we can tell how by what percentage the model thought the object was what. Like I think in this example, wait, give me one second. In this one, let's say for boat it was 94% sure that the image was a boat, but then it was 1% sure that it could be a dog, 4% sure it could be a cat, and then 2% sure it could be a bird. Like that. I guess the accuracy.
Yeah, exactly. It has to think it's something, right? So it has to think it's either a dog, cat, boat, or bird with a probability of 100%. So the individual probabilities that it thinks it's one of those things all have to add up to 1. So yeah, good explanation, Tachor.
Thank you. Any more questions?
Yeah, good job, Aparna, with your explanation about probability as well. Okay, I think we're done then. We can move on to the notebook right now. So Tajwar, if you could just go to the last slide, or Tajwar just put in.
I put it in the link in the Google Meets chat.
Yeah. Okay. So this is our lesson for today. If anyone's interested, we'll post the notebook on Facebook or on Discord or on the Hangouts. But thank you for listening to our little lecture on convolutional neural networks, and we'll see you Tuesday or the next Tuesday from next Tuesday. Bye.